So next we have Omar Baldonado. Omar is a veteran of software-defined networking, first being the effective VP engineering at Big Switch Networks and then moving on to Facebook. Facebook has been really interesting, not only in how you run networks, but also how open you are about the hardware that you use and the software that you use. So I'm very excited to hear what you've been doing lately.
Great.
Omar.
Thanks. And thank you all. So my name is Omar. I'll be talking about some of the experiences that we've had in open sourcing network hardware and software. This is work from the Facebook network team, a lot of folks there, as well as within the Open Compute project. And I'll actually talk about a few of the projects we have going on there and how those will relate and I think complement very well the open source direction that we have here within the ONF. So just to review, Facebook has got a global network, right? We have data centers, we have a global backbone, edge presence throughout the network, and we're even getting into the last mile, wherein we have bringing connectivity to the next billion users. From a scale perspective, we also have a lot of traffic that we deal with, both egressing to the internet as well as to kept within internal to our network. So what I'll focus on today is actually the part where we've done the most work in terms of open sourcing hardware and software, and this is within the data center. And the data center, we started a sort of a rework of this over the past few years. And we've been pretty public about this, so I'll just kind of go through this quickly. The topology we've talked about, a fabric, a cloth fabric, the hardware, wedge and six-pack, and then the software. Software on top of it is called FBOSS, and there's actually a talk later this afternoon by the lead of our FBOSS team covering FBOSS design. So why did we develop all of this hardware and software? And why did we kind of tackle this new data center? Mostly it was for flexibility and speed, right? And the previous speakers have already covered this. The benefits you get in terms of monitoring, provisioning and automation, debugging, troubleshooting, as well as control, all are very compelling reasons for why we started down the route of writing the software ourselves. Now the next question is, after why did we write this, why do we proceed within open source, right? Now open source is something that's just part of Facebook culture, right? Ever since Mark in a dorm room pulled down a PHP stack and MySQL and launched this thing called the Facebook, open source has been part of the culture. And now at this point, Facebook by some measures is one of the largest, if not the largest, open source company in the world. We have projects ranging all the way from from infrastructure up to app development, JavaScript stacks, that sort of thing. So how do we bring those open source concepts to the network? The way we started this off was learning on how we brought open source to the hardware world. And this is something called the Open Compute project. Now, the Open Compute project, we started about 4 years ago. We contributed a number of designs, servers, rack designs, data center designs, storage. But there was something missing as of 2 years ago. We didn't actually have a network that was part of this open source hardware community. So a couple of years ago, a number of members of the OCP community, as well as here within ONF, we got together and we said, what do we need to do to make the networking industry more open? And so we came together and we had a brainstorming meeting at MIT, and we talked about a couple of concepts, disaggregation and being open. Open, I think, we'll cover throughout the rest of the talk, but I wanted to focus a little bit on disaggregation. Disaggregation has been talked about in a number of ways: control plane, data plane separation, hardware, software separation. There are a number of ways to think of this, and mostly what we wanted to focus on was how do we break apart that which has been mostly monolithic, right? How do we have hardware, let's say, that's sold by one vendor, and then we can get software from another vendor, or open source software that we put onto it ourselves. And so this is something that we've been pushing for the last couple of years, and happy to report at this point that network disaggregation has started, and it's here. So you can actually get hardware that is bare metal network hardware. You can get software libraries on top of it. And they're all different libraries that you can put on top of this, this hardware. And there's actually a large testing initiative that we have going on to make sure all of these pieces are interoperable. So I'll cover some of these in a little bit in detail. So from the hardware perspective, we have open network hardware switches that are available bare metal, as well as with software that you can load on it separately. And this is in different form factors, mostly for data center, 48 by 10, 32 by 40. Even we have contributions now at 100 gig speeds. Just to give you a shout out, because I know we talk a lot about hardware here. This is software. This is a little shout out to the hardware folks. What does open network hardware really mean? And if you go and check it out, it's actually just, it's amazing how much openness there is in the hardware space. I'll take our own hardware switch just as an example. You can see a specification with a high-level block diagram of how the switch is laid out, but you can quickly get into details such as wiring diagrams like this, and even if you go in to get the full design package, you'll see schematics, CAD files, 2 and 3D step files, Gerbers, BOMs, FPGA code. All of this is now available for the public to see, and for more importantly, for people to start consuming as well as to riff on. So if I take a look, this is again out of the package, QSFP connectors, FPGA logic, I2C buses. All of this is there as open hardware. Then I think really excited. This wasn't there 2 years ago. This wasn't there a year ago. And now this is available. So let me switch now to the software side of things. Right? So I get these hardware switches. I can change them and build them myself. I can go to a manufacturer and say, I'd like to change it this way. I need more ports here. I need more ports there. But now what sort of software do you want? Right? And within the OCP, we really focused on providing software building blocks, right? Initially. As a software diagram, there are any sort of layers that you can take a look at. I'll focus on the bottom few layers because those are the components that we've focused on first. So as an example, you need a way, if I buy a bare metal switch and I'm going to run software from somebody else, a different vendor from whom I've bought the switch, I need a way to load that network operating system on there. So there's a project called ONI that is part of OCP that lets you load on a different network operating system, or any network operating system that's compatible with the ONI spec. This is now available across dozens of switches. There's a whole testing effort to make sure the NOSes are compatible and switches are compatible with this. So we're really enforcing this disaggregation concept where you can get software loaded onto your hardware switch from other vendors. Kind of as the next step, we have Open Network Linux, which provides a base operating system. There are multiple vendors participating here. You can think of it as, it's not yet quite the full forwarding application, but it's the operating system for everything that you need to get the switch going. Fan control, environmental control, how do I talk to the PHYs and bring up the interfaces, shut down the interfaces. All of that is part of this basic platform code. It's a great start for other people trying to do open source development. It's a great start for people doing research, again, as a building block. And fan control is part of it. So moving up the stack, there are a couple of higher layer libraries that I wanted to highlight. One is the switch abstraction interface. This is a multi-company effort to basically take the SDKs on the switch and abstract them out so that applications on top write to one interface. There's been a lot of progress actually in the switch SDKs themselves. They're now open increasingly. Broadcom and Mellanox have both announced that these are open so that, again, this is focusing on switch side agent development. And I think that actually complements a lot of what the controller side community wants to do, because you want to have innovation as well on the switch so that you don't have to wait for others to do that development for you. There are a number of companies participating very actively in this. In fact, Dave's group at Microsoft is the active driver for it, along with folks from Dell, Broadcom, and Mellanox. Near and dear to my heart is the Facebook operating system, FBOSS. This is actually in production in Facebook data centers. It has a number of libraries that are part of it. We've open sourced one called the FBOSS agent. It's the lowest level interface to the ASIC. It has a thrift interface for any other software components to program. And there's a lot more info on this in the afternoon session from Adam. So that's just kind of a quick survey of the different packages, hardware and software that we've been participating with and helping to drive over the last couple of years. So let's take a look at what the next steps are. First of all, just click through this. From a hardware form factor perspective, we're looking at moving beyond the top of rack, moving beyond the data center, moving to 100 gig plus speeds. From a software perspective, we want to keep on driving disaggregation. Right? We really want to force and as much as possible, have everyone think of all the different layers that you can provide in the hardware stack and the software stack, and make sure that you're not locked into any one vendor. I shouldn't have to buy my optics from the same company that sells me the switch. I shouldn't have to buy the software, any of the software from the same vendor that sells me the switch. If I'm using this application, I'd love to be able to use it in this operating system, using this library and this chip, and I'd love to use that same application on another chip. In the end, we're not really trying to enforce, I think Guru talked about this at the opening, we're not really trying to enforce a lot of standards here in the open source community. We're really trying to have as much modularity and openness as possible, and then we'll just see how different implementations evolve over time. Finally, the part that I think is the most interesting in terms of the relationship between the community that I just described with this open source hardware and these low-level software building blocks and the ONF and what's going on here is building a whole open source ecosystem. Right? How do we get the work such as Atrium? How do we get that to be built on top of OCP switches? And how can we provide full open source stacks that are deployable, production quality, and hardened? This is something I think that is a great opportunity for us to keep on collaborating with as we go forward. A very common mantra that we have at Facebook is that we're only 1% finished in this, even though I'm very proud of all the work that a number of us have been participating with. It's been a lot of excitement driving this with the rest of the operators and vendor community. There is a lot to do. So we welcome your open source hardware and network contributions and look forward to more collaboration. Thank you.